Students, we were discussing work energy and power from H.C. Verma in our last class. I would like to discuss it from the NCERT book so that you can understand it better, because you also have the NCERT book. So first I have already introduced about work and energy and power. Let us study about the scalar product. What the scalar product is. When we are taking scalar product of two vectors, it is defined as A dot B dot is equals to AB cos theta. Dot product of two vectors is always a scalar, where theta is the angle between two vectors. Since AB and cos theta are scalars, the dot product of A and B is a scalar quantity. Each vector A and B has a direction, but the scalar product does not have a direction. From that equation, A, B cos theta, B, geometrically B cos theta is a projection of B into A and A cos theta is a projection of A into B. So A dot B is the product of magnitude of A and component of B along A. Alternatively, it is the product of the magnitude of B and the component of A along B. Equation shows the scalar product follows the commutative law. A dot B equal to B dot A. Scalar product obeys the distributive law. A dot B plus C equal to A dot B plus A dot C. Further, A dot lambda B equal to lambda A dot B, where lambda is a real number. The proofs of the above equations are left to you as an exercise. For unit vectors I, j, cap, this you can refer from your book. But if you have two vectors, A equal to Ax I cap plus Ay j cap plus Az k cap. We have another vector B equal to Px I cap plus Py j cap plus Pz k cap. When we take the dot product, A dot B, we are dotting Ax I cap plus Ay j cap plus Az t cap, and then dot with Bx I cap plus By j cap plus Bz k cap. কোন পাখা? হ্যাঁ, এটা বন্ধ করে দাও। পাখাটা বন্ধ করে দাও। এই পাখাটা বন্ধ করো না। পাখাটা বন্ধ করলে ভালো ঠান্ডা হবে। না, আমার খুব গরম লাগবে। এটা বন্ধ করে দেখি একবার। না, বন্ধ করো না। আমি গরমে মরে যাবো। একবার দেখ। তোমার যা ইচ্ছা তুমি করতে পারো। তোমাকে আমি কি বলবো? গরম লাগবে আমি কেন করব? ভাই গরম লাগছে। আমার ভিডিও চলছে। is equals to Ax Bx plus Ay By plus Az Bz. Ax Bx plus Ay By plus Az Bz. From the definition of scalar product, A dot A equal to Ax plus A, this is defined. Find, now there is one numerical, let us solve it. Find the angle between force, this so and so, and displacement so and so. Also find the projection of F on D. F dot D they have done. F dot D equal to Fd cos theta is equal to 16. F dot F equal to F equal to 50 units. D dot D equal to 50 units cos theta. Okay, so they have done some calculations here. You can try to solve this on your own. If you have any doubt, we will discuss this in the class. Notions of work and kinetic energy theorem. The work energy theorem. The following relation for rectilinear motion under constant acceleration A has been encountered in chapter 3. V square minus u square equal to 2as, where u and v are the initial and final speeds and h is the distance travelled. Multiplying both sides by m by 2, we have so and so. The last step follows from Newton's. Okay. So what the work done by a force on the body over a certain displacement. The change in kinetic energy of a particle is equal to the work done on by the net force. There's one numerical here which you can try to solve on your own. Try to solve the numericals on your own and we will discuss in the next class. Try to solve the numericals and we shall discuss this in the next class. Work. As seen, now we will discuss about work. As seen earlier, work is related to force and the displacement over which it acts. Consider a constant force acting on an object of mass m. The object undergoes a displacement d in the positive x direction as shown in figure 5.2. The work done by the force is defined to be the product of component of the force in the direction of displacement and the magnitude of this displacement. This work is F cos theta d. So work done by the force, it is defined as that component along the displacement. So work is equal to F cos theta d. We see that if there is no displacement, there is no work done, even if the force is large. Thus, when you push hard against a rigid brick wall, the force you exert on the wall does no work. Yet your muscles are alternatively contracting and relaxing and internal energy is being used up and you get tired. Thus, the meaning of work in physics is different from its usage in everyday language. No work is done if the displacement is zero as soon as in the example. Okay, so you can refer this on your own. There is one numerical, you can try to solve it. If you have any doubt, I can solve it for you. Now the kinetic energy I already know. Now we have to see the work done by a variable force. What is the work done by a variable force? Now we will put down the heading work done by a variable force. I am also writing down work done by variable force. Constant force is rare. It is the variable force which is more commonly encountered. 5.3 is the plot of variable. See, if there is a variable force, if I am to plot it, just plot it. F of x, x, there is one graph, this area is equal to delta A equal to f of x, delta x. Constant force is rare. It is the variable force which is more commonly encountered. Figure 5.3 is the plot of varying force in one dimension. If the displacement delta x is small, we can take the force f of x as approximately constant and the work done in that case is delta w equal to f of x delta x. Now we have to sum it. We have to sum it from all the points from xi to x of f. So what do? We sum it. We sum all the forces from x equal to xf, f of x delta x, and put it as w equal to limit delta x tends to 0 summation xi xf f of x delta x is equals to integration again xi xf f of x d of x. Now there are some numericals here. You can try the numericals and on your own. If you have any doubt, you can ask me. Work energy theorem for a variable force is the next topic. We shall discuss that in the next class. Thank you.